In this video, I wanted to show you the applications of differential equations in electrical circuits. Let's say if we have a resistor R and the current going through it, the voltage across that resistor, we can write it as RI. And in an inductance, the voltage across that inductance will be L, the inductance, multiplied by di dt. And if we have a capacitor, and the current going through it, the voltage in this capacitor will be equal to 1 over C, the integration of I dt. Now, the current by definition is the rate of change of charge with respect to time. And we can write that as current is equal to rate of change of charge if Q is on charge with respect to time. So if the current is the rate of change of charge with respect to time, we can write this also as R dq dt, and we can write this as L d square Q over dt square, and we can write this as 1 over C Q. The voltage across the capacitor is 1 over C, the integration of I is dq dt, integration of dq dt is Q. Now, let's say we have a circuit with a voltage E on it, and we have a inductance, a resistor, and let's say a capacitor in that circuit. So the differential equation for a circuit like that, we can write it as we have an inductance L d2q dt square plus a resistor R dq dt plus a capacitor, which is 1 over CQ, is equal to our voltage. So our total voltage is equal to the summation of the voltages in inductance, resistance, and capacitance. So this is the general differential equation for an electrical circuit with inductance, resistance, and capacitance. Now, if we have a circuit that only have resistor and capacitor, this will be our equation. Or if we have a system with only inductance and resistors, that would be our equation. Or if we have or if we have a circuit with only resistance, this will be our equation, and so on. But this is the general form if we have all three in a circuit. Now, let's go ahead and solve a problem. You know, this and these are this N or C. These are the constants of the inductance, resistance, and capacitors. These are the values that the manufacturer will give you. I think I have a roll of. This is a roll of resistors, And when you buy the resistors, if we give you the value of resistor, this one, the R is 1 kilo ohm. So when you buy a resistor, you can choose what ohm you want. So these are the values that the manufacturers will give you. Now let's go ahead and solve a problem. Let's say we have a problem. Let's say that we have a circuit that our voltage is 200 volt, and our inductance is 1. Let's say our resistance is 6 ohm, and let's say our capacitance is 0.04 farad, and by this information we want to find the value for charge. We know charge is a function of time, and also we want to find our current, and the conditions that we are going to have is our Q, our charge, when our time is 0 is equal to 0, and our current at time 0 is equal to 0. So based on these two initial conditions, we want to find our charge and our current. So let's solve this problem. So again, we have a circuit. With the inductance, resistance, and capacitor, and these are the values for inductance, resistance, and capacitors. Let's go ahead and plug those information into this equation. L is 1, so we are going to have d squared q dt squared plus r is 6 dq dt plus c is 0.04, so 1 over c will be equal to 1 over 0.04, so this will be equal to like 100 divided by 4, so will be 25. So our 1 over c is 25, q equal to 200 volts. Now we have a second order non-homogeneous differential equations. I have posted a video how to solve a problem like this. A problem, the general solution for this type of problem will be, the general solution Q will be the solution to the corresponding homogeneous portion of this equation plus the particular solution to the non-homogeneous portion of the equation. So here the solution to the homogeneous portion QC, to solve this we can use the auxiliary polynomial, and we can write this as m squared plus 6m plus 25 is equal to 0. So here we can find the value of m1 and m2, which is equal to minus b minus 6 plus or minus the square root of b squared, which is 36, minus 4ac, which is 100, divided by 2a divided by 2. So this will be minus 6 plus or minus a square root of minus 64 divided by 2. So this will be equal to minus 6 plus or minus a square root plus or minus 8i divided by 2. So this is minus 3 plus or minus 4i. So the general solution, okay, remember those? So the general solution for this will be, or QC will be e to power minus 3t multiplied by C1 sine of 4t plus C2 cosine of 4t. So this is the general solution for the non-homogeneous portion of our equation. So to find the particular solution, for the non-homogeneous portion, we can assume a solution Q as A because we have constant. So if we do that, then our dq over dt will be equal to 0. The derivative of constant is 0. And our second derivative of q with respect to time will also be 0. So if we plug those assumptions in this equation, we are going to have 0 plus 0 plus 25a is equal to 200. So from here, you see 25a will be equal to 200. So our value for a will be equal to 8. So our particular solution will be 8. So the general solution for this non-homogeneous differential equation will be QC. So our general solution will be QC, which is e to power minus 3t times C1 sine of 4t plus C2 cosine of 4t plus 8. So this is our charge. So let me go ahead and write this up here again. Our Q is equal to e to power minus 3t multiplied by C1 sine of 4t plus C2 cosine of 4t plus 8. Now we have the initial conditions that our Q when time is 0 is equal to 0. So if if we go ahead and put that value out here, our Q when time is 0, e to power 0 will be 1 multiplied by C1 sine of 0 plus C2 cosine of 0 plus 8, which is equal to 0. Or Q at time 0 equal to 0. So from here, we can see that sine of 0 is 0 and cosine of 0 is 1. So C2 plus 8 will be equal to 0. So our value for C2 will be equal to minus 8. So our C2 is minus 8. So our C2 here is minus 8. Now we also had another initial condition, our current when time is 0 is equal to 0. And we said that the current by definition is the rate of change of charge with respect to time. So I is equal to dq over dt. So to find I, we need to go ahead and take the derivative of this. So to take the derivative of this, here, first one multiplied by the derivative of the second one, the derivative of this portion will be 4 C1 cosine of 4t, and derivative of this will be, the derivative of cosine is minus sine, minus and minus will be plus, plus 4 times 8, 32 sine of 4t, then plus the derivative of the first portion plus derivative of this will be minus 3 e to power minus 3t multiplied by the second part, multiplied by C1 sine of 4t minus 8 cosine of 4t plus the derivative of 8, which is 0. So if we simplify this, okay, now we have a condition that I at time equal to 0 will be equal to 0. So this equation will be equal to 0 at time 0. So if we plug that information here, we are going to have 0 will be equal to e to power 0 is 1 multiplied by the cosine of 0 will be 1, so that will be 1 multiplied by 4 C1 plus the sine of 0 will be 0 plus 0 plus minus 3 e to power, so plus minus 3 multiplied by 1 e to power 0 is 1 multiplied by this sine of 0 will be 0 minus cosine of 0 will be 1 minus 8. So this will be equal to 0 will be equal to 4C1 plus 24. So C1 will be equal to minus 24 divided by 4 will be equal to minus 6. So our C1 will be equal to minus 6. So if our C1 is minus 6, this will be minus 6 So this is our answer for the charge, which of course we can simplify that. We can write this. We can write that as minus Q is equal to minus e to power minus 3t times 6 sine of 4t plus 8 cosine of 4t plus 8. So this is our Q, and our I, we find the value of C1, which is minus 6. So our I will be equal to e to power minus 3t times minus 6 times 4 is minus 24 cosine of 40 plus 32 sine of 40 then plus e to power minus 3t, multiply that, minus 3 multiplied by C1, so will be minus, C1 was minus 6, minus 18, minus 18 sine of 40, and minus 3 multiplied by minus 3 multiplied by minus 8 cosine of it will be plus 24 cosine of 4t. So if we simplify this, we can write this I is equal to e to power minus 3t multiplied by minus 24 cosine of 4t plus 24 cosine of 4t plus 32 this will be positive because C1 was minus 6. So this will be plus plus 18 plus 32 sine of 40 plus 18 sine of 40. That's it. Which here, these two portions will cancel out. So our I will be equal to e to power minus 3t multiplied by 32 plus 18, 50 sine of 40. So this is our current, and this is our charge. I hope you liked it. I will solve another problem using differential equation in electrical circuit next week. Thanks.